Good day, esteemed researchers and viewers tuning in from around the world. We're excited to present our paper, Matten, Video Generation with Mamba-Attention, authored by Yu Gao, Jiancheng Huang, Xiaopeng Sun, Zichun Jia, Yuji Zhang, and Lin Ma. Our research delves into the realm of video generation, tackling complex challenges like capturing facial motions and dynamic movements. We introduce Matten, a model that not only outperforms existing methods, but also paves the way for future Mamba-based models. Stay tuned for an intriguing exploration of our findings. Moving on to the key highlights of our research. Our primary motivation is to enhance video generation methods with a particular focus on complex scenarios. These include accurately capturing facial motions and handling dynamic movements of athletes, which are challenging tasks for current models. We've addressed the limitations of existing models, such as latent and U-net-based models. These models often struggle when it comes to generating high-quality videos on complex datasets like UCF101. Our proposed solution, Matten, overcomes these challenges, demonstrating superior performance and scalability. In the next slides, we will delve deeper into the specifics of our model and its impressive results. Stay tuned to learn more about how Matten is revolutionizing video generation. Begin frame title. Our novel approach. Matten, begin itemize. Item. Our research led us to propose a new model, Matten, which leverages the Mamba-Attention structure for efficient video generation. Item. We've explored different configurations of Matten, including 4 model variants, time step and category information injection, and model size. Item. Our findings show that Matten excels in 4 standard video generation benchmarks and displays impressive scalability. Item. We've also found that the Mamba model, which is integral to Matten, significantly improves the efficiency of data inference processes and the overall performance of models. Item. Despite its limitations in detecting localized data patterns, the Mamba model's dynamic parameters and algorithms tailored for better hardware compatibility make it a valuable tool in our approach. End itemize. End frame. Begin frame title. Exploring model variants. Begin itemize. Item. Model variants. Begin itemize. Item. We designed 4 model variants to explore the optimal combination of Mamba and attention in video generation. Item. These variants helped us understand the best way to capture local spatio-temporal details and global information. End itemize. Item. Performance and scalability. Begin itemize. Item. Matten not only achieves comparable performance to other models, but does so with lower computational and parameter requirements. Item. It also exhibits strong scalability, with a direct positive relationship between the model's complexity and the quality of generated samples. End itemize. End itemize. End frame. In our quest to optimize video generation, we experimented with 4 distinct model variants of Matten. These variants allowed us to explore the perfect blend of Mamba and attention mechanisms, enabling us to effectively capture both local spatio-temporal details and global information. But that's not all. Matten's performance is on par with other models, but it achieves this with fewer computational and parameter requirements. Plus, it's highly scalable. As we increase the model's complexity, the quality of the generated samples improves correspondingly. This scalability is a testament to Matten's potential in the realm of video generation. Begin frame title. Key highlights. Begin itemize. Item. We've proposed a novel diffusion method for video generation, Matten, using the Mamba-Attention structure as the backbone. Item. We've explored different configurations of the model, including 4 model variants, time step and category information injection, and model size. Item. Our extensive experiments show that Matten excels in 4 standard video generation benchmarks and displays impressive scalability. Item. We've conducted an ablation study using the Sky time-lapse dataset, which shows that larger models tend to deliver improved performance. End itemize. End frame. Begin frame title. Unveiling Matten, a new approach to video generation. Begin a figure. Centering. Include graphics. Width equals 0.8 text width. Height equals 0.45 text height. SRC. Task _ execution extracted _ paper _ data. 2405.03025 v1. Figures. 2405.03025v1 figure 9:1.png, captiona tinea Matten's performance on various datasets. End of figure. Begin itemize. Item introduction to Matten. Begin itemize. Item a diffusion method for video generation. Item uses Mamba-Attention structure as the backbone. Item excels in standard video generation benchmarks. Item displays impressive scalability. End itemize. Item Matten's superiority. Begin itemize. Item surpasses prior works in video generation. Item matches performance of methods with image pre-trained weights. Item achieves a 25% reduction in flops compared to latest Transformer-based model. End itemize. End itemize. End of frame. Backquote. Begin a frame. Frame title our solution. The Matten model. Begin a figure. Centering include graphics. Width equals 0.8 text width. Height equals 0.45 text height. SRC task underscore execution extracted underscore paper underscore data. 2405.03025v1. Figures. 2405.03025v1 figure 9:1.png, captiona tinea Matten model performance on various datasets. End of figure. Begin itemize. Item the Matten model. A new approach. Begin itemize. Item utilizes the Mamba-Attention structure for video generation. Item excels in 4 standard video generation benchmarks. Item demonstrates impressive scalability and robustness. End itemize. Item superior performance. Begin itemize. Item outperforms existing models. Even those with image pre-trained weights. Item achieves a 25% reduction in flops compared to the latent model. Item particularly effective on complex datasets like UCF101. End itemize. Item future potential. Begin itemize. Item currently trained from scratch due to lack of pre-trained Mamba-based models. Item anticipated improvement in training efficiency with the release of Mamba-based image generation models. End itemize. End itemize. End of frame. Backquote. Begin a frame. Frame title experimental findings and conclusion. Begin a figure. Centering include graphics. Width equals 0.8 text width. Height equals 0.45 text height. SRC task underscore execution extracted underscore paper underscore data. 2405.03025v1. Figures. 2405.03025v1 figure 9:1.png, captiona tinea performance analysis of Matten on various datasets. End of figure. Begin itemize. Item our experiments were conducted on the Sky time-lapse dataset, among others. Item larger models showed improved performance, validating the benefits of scaling up model dimensions. Item the Matten model, with its Mamba-Attention structure, proved to be an effective tool for video generation. Item our model outperformed others in 4 standard video generation benchmarks, demonstrating its impressive scalability. End itemize. End of frame. Backquote. Begin a frame. Frame title a delving deeper. Ablation studies and experiments. Begin a figure. Centering include graphics. Width equals 0.8 text width. Height equals 0.45 text height. SRC task underscore execution extracted underscore paper underscore data. 2405.03025v1. Figures. 2405.03025v1 figure 9:1.png, captiona tinea impact of model size on performance. End of figure. Begin itemize. Item unpacking the power of Matten. Begin itemize. Item ablation studies reveal the influence of design modifications and model size on performance. Item larger models tend to deliver improved performance. A trend consistent with other studies in image and video generation. Item our experiments, conducted on various datasets, provide a comparative analysis against advanced video generation methods. End itemize. End itemize. End of frame. Backquote. Begin a frame. Frame title are the power of Mamba and the birth of Matten. Begin a figure. Centering include graphics. Width equals 0.8 text width. Height equals 0.45 text height. SRC task underscore execution extracted underscore paper underscore data. 2405.03025v1. Figures. 2405.03025v1 figure 9:1.png. Captiona tinea, Mamba's universal approximation capabilities and efficient modeling of long sequences. End of figure. Begin itemize. Item the rise of Mamba-based models. Begin itemize. Item Mamba's universal approximation capabilities and efficient modeling of long sequences have made it prominent in deep learning. Item Mamba has been applied in diverse fields such as medical imaging, image restoration, graphs, NLP, and image generation. Item Despite the computational demands, Mamba has been able to address long-range dependencies. And itemize. Item The birth of Matten. Begin itemize. Item Our method Matten is designed to encompass global temporal dimensions, diverging from previous research focused mainly on local temporal modeling. Item Matten uses the Mamba-Attention structure as the backbone for generating videos. Item Extensive experiments demonstrate that Matten excels in 4 standard video generation benchmarks and displays impressive scalability. End itemize. End itemize. End frame. In our exploration of related works, we delve into the realm of diffusion models in video generation. These models have made significant strides recently, showcasing their impressive capabilities. However, it's not just about the models themselves. The architectural design plays a pivotal role in their efficient application. This means that the structure of these models is just as important as the models themselves. It's like building a house. The materials matter, but without a solid blueprint, the house won't stand. In the same vein, a well-designed architecture can significantly enhance the performance of diffusion models in video generation. In the next slide, we will delve deeper into the specifics of these architectures and their impact on video generation. In this slide, we delve deeper into the related works, specifically focusing on CNN-based U-Net architectures and Transformer-based frameworks. These models are known for their use of attention mechanisms to process spatio-temporal dynamics in video content. Spatial attention, in particular, is a key component in both U-Net-based and Transformer-based video generation diffusion models. However, a significant challenge these models face is their inability to effectively capture interrelations across varying spatial positions in successive frames. This limitation underscores the need for innovative approaches to address this issue, which we will explore in our proposed model, Matten. In our exploration of related works, we delve into the realm of state space models, or SSMs. These models have been making waves across a multitude of fields, largely due to their adeptness at handling long sequences of data. This makes them particularly useful in areas where data is sequential or time series in nature. One standout innovation in this space is the Mamba model. Originally developed for natural language processing, or NLP, Mamba has significantly enhanced the efficiency of data inference processes and the overall performance of models. It achieves this by introducing dynamic parameters into the SSM structure and by building algorithms tailored for better hardware compatibility. These advancements have not only improved the way we process data, but have also opened up new possibilities for the application of these models. So, as we move forward, let's keep in mind the potential of these powerful tools and how they can be leveraged in our own research. In this slide, we delve into the limitations of existing models in the field of video generation. Models such as latent, a transformer-based model, and U-Net-based models like stable diffusion or SDXL have shown certain shortcomings. For instance, these models often struggle when tasked with generating high-quality videos on complex datasets, such as UCF-101. Additionally, the current landscape lacks released, pre-trained Mamba-based image generation models. This absence restricts the training options for these models, limiting their potential. As we move forward, it's crucial to address these limitations to enhance the efficiency and effectiveness of video generation models. Begin a frame. Frame title: Matten's performance and scalability. Begin itemize. Item Matten's performance. Begin itemize. Item Matten consistently delivers realistic video generations at a high resolution of 256 by 256 pixels. Item It excels in generating high-quality videos on the UCF-101 dataset, a challenging area for many models. Item Quantitative results show that Matten surpasses prior works and matches the performance of methods with image pre-trained weights. End itemize. Item Matten scalability. Begin itemize. Item Matten achieves a 25% reduction in flops compared to latent, the latest transformer-based model. Item Despite being trained from scratch, Matten demonstrates superior video generation capabilities. Item The availability of Mamba-based image generation models in the future will further enhance Matten's training. End itemize. End itemize. End frame. On this slide, we delve deeper into the technical details of our proposed method, Matten. As you can see in the figure, we illustrate different ways of spatio-temporal modeling using Mamba-Attention. This is the backbone of our Matten model. It's designed to capture both local spatio-temporal details and global information, which is crucial for efficient and superior video generation. Matten is a novel video latent diffusion model. It's integrated with the Mamba block and attention operations. These components work together to make Matten not only efficient, but also superior in generating videos. This unique combination of Mamba and attention operations is what sets Matten apart and allows it to excel in video generation tasks. Begin a frame. Frame title: a model evaluation and results. Begin a figure. Centering: include graphics. Width equals 0.8, text width. Height equals 0.45, text height. SRC: task _ execution extracted _ paper _ data. 2405.03025v1. Figures 2405.03025v1 figure 2:1.png. Captiona Tinea performance comparison of Matten with other models. This figure showcases the impressive scalability and efficiency of Matten in video generation tasks. End a figure. Begin itemize. Item performance analysis. Begin itemize. Item Matten's performance compared with state-of-the-art models. Item demonstrated scalability and efficiency in video generation tasks. Item positive correlation between model complexity and quality of generated samples. End itemize. End itemize. End a frame. In this slide, we delve into the performance of our proposed model, Matten. As you can see in the figure, we've compared Matten's performance with other state-of-the-art models in video generation tasks. The results are quite promising. Matten not only holds its own against these models, but also showcases impressive scalability and efficiency. Interestingly, we found a direct positive correlation between the complexity of the model and the quality of the generated samples. This suggests that as we increase the complexity of Matten, we can expect even better results. On this slide, we delve deeper into the technical details of our proposed research. The figure you see here illustrates the different ways of spatio-temporal modeling using Mamba-Attention. This is the core of our novel video latent diffusion model, Matten. The Mamba-Attention structure serves as the backbone for video generation. It's designed to capture both local spatio-temporal details and global information, providing a comprehensive understanding of the video content. However, the Mamba block has its limitations. It struggles to effectively detect localized data patterns. To address this, we've adopted attention mechanisms, which are known for their ability to capture these details. This combination of Mamba and attention mechanisms allows Matten to generate high-quality videos efficiently. In this slide, we delve deeper into the technical aspects of our proposed research. The figure you see here illustrates the different ways of spatio-temporal modeling using Mamba-Attention. This is the backbone of our Matten model, which efficiently captures both local spatio-temporal details and global information, leading to superior video generation. Now, let's talk about our experiment design. We trained our model on 4 diverse datasets: UCF101, Tai Chi, HD, Face Forensics, and Sky Timelapse. This allowed us to evaluate the performance of Matten in both unconditional and conditional video generation tasks. The results, as we will see in the following slides, are quite promising. Stay tuned. Moving on to our proposed research and technical details, let's take a closer look at this figure. It illustrates the different ways of spatio-temporal modeling using Mamba-Attention. As you can see, the Mamba-Attention structure forms the backbone of our proposed Matten model. This structure is designed to capture both local spatio-temporal details and global information. This dual approach allows for efficient and superior video generation. The Mamba model, originally developed for natural language processing, has been adapted here to handle the complexity of video data. However, it's important to note that while Mamba is excellent at capturing global information, it struggles with detecting localized data patterns. To address this, we've integrated attention mechanisms into our model. This combination allows Matten to excel in both local and global data processing, leading to impressive results in video generation. On this slide, we delve into the technical results of our study. As you can see from the figure, We've conducted extensive ablation studies to explore various design choices. These investigations were carried out using the Sky time-lapse dataset. Our findings indicate a clear trend. Larger models tend to deliver improved performance. This echoes findings from other studies in image and video generation, underscoring the benefits of scaling up model dimensions. We've also explored different configurations of our proposed model, Matten, including 4 model variants, time step and category information injection, and model size. The results: Matten excels in 4 standard video generation benchmarks and displays impressive scalability. This is a testament to the power of our simple diffusion method for video generation, with the Mamba-Attention structure as the backbone. Begin frame title conclusions and remarks, begin itemize. Item: we've proposed a novel diffusion method for video generation, Matten, utilizing the Mamba-Attention structure as its backbone. Item: our extensive experiments have shown that Matten excels in 4 standard video generation benchmarks, demonstrating impressive scalability. Item: we've explored different configurations of the model, including 4 model variants, time step and category information injection, and model size. Item: our ablation study on the Sky time-lapse dataset revealed that larger models tend to deliver improved performance, reinforcing the benefits of scaling up model dimensions. End itemize, end frame,